Yes, hi again. This is George Lerakis, and today I would like to talk about how you do double integration by parts, special case. First of all, let's start with the one. You use this case here. You use this case when, of course, this is the integration by parts rule. So you have the integral of f of x g prime of x dx is equal with f of x gx minus the integral of f prime of x gx dx. So that's the formula for integration by parts. This integral here is supposed to be something which we can calculate, but sometimes this cannot be calculated. So that means that you have to continue, and as I said before, it might be also more than a double integration, but this integral has to be easier than this here. But in this case, the special case that I will be talking, this integral and this integral, they are exactly of the same level of difficulty, and actually they are very similar. So now when you have this here, you have to go and integrate again this here. So and that will give you, let's say, an integral g of x plus a constant times this integral that we started. So that's when you have to do this double integration by parts. So the theory here is that is the rule that we already mentioned. And let's now continue with an example. So let's say that we have to find the integral of e of x cos 2x dx. So here, if you try any other way of calculating this integral, you cannot. So that means that you have to do integration by parts. And what we substitute here, we substitute the e of x to be the f and the cos 2x to be the g prime of x. So that means that you have to find the integral of cos 2x. So this integral here, it's by symbol substitution. You will find that it's equal with sine 2x over x. It's a pretty simple substitution. You just have to substitute u equal with 2x. So this here is the integral of cos 2x. So that means that if you go back to the formula here, and you use the rule of integration by parts, that means that you have here f of x, which we said is e of x. Here you will have the g of x, which it will be this here, the sine 2x over 2, and then of course here it should be minus f prime of x. So that means we said f of x is the e to the x. So that means that this the derivative of e to the x, which is e to the x, times the g of x, which we said already is sine 2x dx over 2. So now you see that, this integral here, it's exactly the same level of difficulty with this integral here. So that's, what we mean by special case. You have now to find the integral, you have to find this integral here. So again here you use, that's why we call it double integration by parts. So you use again integration by parts. Your f, it will be the e of e to the x. The g prime of x will be the sine 2x dx. And now since the g prime of x we said is sine 2x, so that means that the integral of this it's equal with minus cos 2x over 2, and that's again as exactly this here, a very easy integral to calculate. It's just by substitution. You substitute u equal with 2x. Then if we continue with the integration by parts rule, that should be equal with f of x, which is e to the x, g of x, which is this here, so that should be minus cos 2x over 2. That's why the minus comes here. And then it should be minus minus the f prime of x, which is the derivative of e to the x, which is e to the x, g of x, which we said is minus cos 2x over 2. So the minus with the minus from here, it will become plus, and of course it will become e to the x cos 2x over 2. And now what we see what exactly we have here, that the integral that we get here, I mean, if you take out the 1/2, which is the constant, you have that this integral here, it's exactly the same with this here. So, and now what we do, we just go back here, and if you substitute here what we do, we should substitute this integral here from here. So that means, we take out the minus 1/2, and we do the substitution here, e to the x cos 2x over 2 plus 1/2, the integral of e to the x cos 2x dx. This is an equation with an unknown, the integral e to the x cos 2x. So if you do here the calculations, you multiply this by minus 1/2, so that will become plus 1/4, and this will become minus the minus minus 1/4. So, and if you bring the 1/4 e to the x cos 2x dx, which we said you treat it as your variable, so here you will have 5/4 of e to the x cos 2x dx. If you do these calculations here, what you will get that this integral here that we were trying to find is equal with 2 2/5 e to the x sine 2x plus e to the x cos 2x over 5, and of course, sorry that I forgot, plus c, since we're talking about an indefinite integral. So that's how you do this special case of double integration by parts. So thank you for taking the time to view this video, and I hope you find it useful, and bye for now.